Hello guys, today we're going to solve this Leetcode question which is bitwise and of numbers range. And in this question we are given two integers left and right that represent the range between left and right. Return the bitwise and of all the numbers in this range. Both this left and right are inclusive. It is fairly easy problem statement to understand. We're just basically given a left and right, and we just need to return the bitwise and of all the numbers between this range. Suppose if we are given 1 and 5, we just need to return 1 bitwise and 2 and 3 and 4 and 5. So you might think, this question is very easy, right? But is marked as medium. So there might be something that they will be twisting, right? So that something is nothing but the constraints. If you look at the constraint here, so look at the look at the constraints, the left value can be 0, the right value can be 2 power 31 minus 1, which is mostly equal to this thing, If you start a loop from 0 and go till 2 power 31 minus 1, you know, uh, this will be the number of times you will be iterating, right? But the maximum limit that we can iterate is 10 power 8. You know, this is the maximum time limit. These are the number of instructions that can be executed in 1 second. Basically in the coding questions, we're basically given 1 second to execute our code, right? So in that 1 second, we can execute a maximum of 10 power 8 instructions. But here in the worst case, the left will be 0 and the right will be 2 power 31 minus 1, right? So which is 21 times greater than the maximum time limit. So if you use this approach, like going from left to the right and doing bitwise and of each and every value, the value the you'll get a TLE, right? You'll get a time limit exceeded. So this approach won't work. So we need to think of another approach so that we can solve this question in a more efficient way. So before that, we need to understand the uh, okay, okay, we need to understand the property of and. So suppose we have 0 and 1. When we do and, it will be 0, right? And when we have 1 0, it will be 0 again. When we have 1 1, then only it will be 1, and when we have 0 0, it will again be 0, right? So when we only have 1 and 1, then only the bitwise and will be 1, right? So using this property, we can solve this question in a more efficient way. Like when you are going from left to right, at particular point, if you identify that your bitwise and is 0, there is no point in going this side, right? Because the bitwise and value till here is 0, and even if you do and with these values, it will be 0 again. Suppose, you know I'll give you an example. Like suppose you have 1 0 0 1 0 0 1 0 1 1 1 0. If you observe carefully, when you do bitwise and between these two values, it will be 0. Here also it's 0. Here also it's 0, right? So after doing the bitwise AND of these two values, even though if you do bitwise AND of these two values, it will be 0 again, right? So there is no point in doing bitwise AND for each and every value. Once our once our bitwise AND becomes 0, then we can stop, right? Suppose here our value is 0 1 0, and when we did bitwise AND with this value, our value has become 0. So there's no point in doing bitwise AND with these two values. And no matter if there are some thousand values as well, will if we encounter 0 in between, we at the end the answer will always be 0. So this is one of the optimization that we can make, and that's it. The first idea that came to my mind when I saw this question is that, I know that, if I have any zero, suppose if I have, there is a number called 11111, and there are so many numbers in between. There are so many ones. Let's say there are all ones. Each and every value is one. Each and every value is one. And I encountered zero at here, and all the remaining numbers are one itself. When I encounter zero in a particular column, then all then no matter how many ones are there in that particular column, my result will always be zero, right? So this will be one, 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 one. It will remain same, but the column which has zero will have zero at the end. Suppose if there is a zero here, then there will definitely be zero here, right? So using this idea, what I thought was, never mind. Using this idea, what I thought was initially I'll take 32 ones. 2, 3, 4, 5, 6, 7, 8, 9. So on 32 ones, this will be my let's say some n. This will be my n, and initially I'll start from left. Initially I'll start from left and I'll go to the right and I go till right, right? Suppose my left value is 16 and my right value is 20. So for 16, the last four digits will be 1, 2, 3, 4, right? So all these values will be 0 itself. 0, 0, 0, 0, 0. This all will be 0. And for 20, the bitwise will be 1, 0, 16, 8, 20, and 0, 0, right? And all the values behind these values will be 0, right? So what I'll do is, I'll start from left and I'll do normal bitwise AND operations, and whenever I see all my values will become 0, then I'll just return 0. Then I'll just return 0. Otherwise, I'll keep on doing the AND operation. So this is the idea that I got into my mind. So let me explain this example using a small group of digits. Suppose if I have 5 ones, let's say this is the n that I told you about. Suppose my left is 16. 1, 0, 0, 16, right? 1, 0, 0, 0, 0. And I'll go till my right, right? So my right will be 1, 0, 1, 0, 0, right? So what I'll do is I'll do AND of these two. It will become 0, 0, 0, 0, and 1, right? Then then there will be L plus 1, right? L plus 1 will be 1, 0, 0, 1. So I'll again do the AND between these two values. Then I'll again get this value, right? So this is not a good example. So I wrote a better example here. So suppose my left is 1 and my right is 6, right? So what I'll do is I'll take a n value which has all bits as ones. So what I'll do is I'll do the bitwise and between these two. Then the answer will be 0, 0, 0, 1, right? These three bits will become 0 and this will be 1. And then I'll again do bitwise and between these two. Then it will become 0, 0, 1, 0. If I do bitwise and between these two, it will be 0, 0, 0, 0, right? So at this point I got a 0, right? then there is no point in doing bitwise and with all these values, right? Suppose the let's say the R will be 6 lakhs. If it is a 6 lakhs, there's no point in doing for all the values till 6 lakhs, right? So if I get a 0, I'll just return 0. I'll just return 0. So this is the approach that I got into my mind. So I'll quickly show the code. N will be integer dot max value. This N contains all ones. That's why we took integer dot max value. So what I'll do is while yeah while my N is not equals to 0, I'll do N and equals to left on the left plus plus. I'll go, oh, I can also do something like this, right? What I can do is I'll take a I equals to left and my I goes till right. I'll increment my I. If at any point my N becomes 0, I'll just return 0. Or at the end, I'll just return the value of my N, right? If I run this, time limit exceeded. This is because, I'm taking this test case. I know that this approach will fail for that particular test case, but it will get accepted for most of the test cases. I guess only one or two test cases will fail using this approach. Look at this. We have passed 8,266 test cases out of 69. So only 3 test cases are getting, failed. So we can also solve this by using long. I can just use long here, long here. Let's try to solve this. I just need to return the int value, right? The return type is int, right? So I need to return the int. If I submit now, only one or two test cases. Oh my God. Okay, never mind. I don't know. So for these test cases, our code will never run with using this approach. So we need to find a more efficient way. Efficient way. The efficient way will be, you observe carefully. Suppose if I have 16 and suppose if I have 32. For 16 it will be 1 0 0 0 0, right? And for 32 the it will be 5 zeros, 1 2 3 4 5. So till 31, so the value of 31 will be 1 1 1 1 1, right? So between these all the values, these 4 bits might change, right? These 4 bits might change, but this one and this one will remain same, right? This one and this one will remain same. Then let's say this is your left and this is your right. So if you even if you do and between all these values, you'll be left with this one, right? But all these values will be zeros because this one has never changed in between. You'll have the same one for all the values in between, right? So and if you take your left as, let's say if you take your left as 1 2 3 31 32 5 and your right is 60 This is 32, right? So this is 60. This should be 63. You have something like this. This one will never change in between, right? All these values may change, but this one will never change, right? So because of this one, you'll be having one here, and no, all these values will be zeros. So what we can do is we can just identify the common elements from the left. Suppose if you have something like 100, 101, and for your right, if you have something like 100, 010, no matter what elements you have in the middle, you know, let's say these three values are same for all the values. This will become 0, right? 1 and 0 will be 0. 0 and 1 will be 0. 1 and 0 will be 0. So these values are same, right? So we'll get 100. So we just need to identify the the common bits the left between the left and the right? We just need to identify the common bits between the left and the right, starting from the left. So if we identify these values, we can put the rest of the values as zeros, because these values will are changing, right? When the bits change, the value will become 0, right? So we just need to identify the common values. Let's take an example. If I have something like 111010110, this is my left. If I have my right as 1111010. Suppose if I have something like this will become 0. This will In between, this will change, right? From in between left and right, this one will definitely will there will be one element which has 0 at this position. So this will also be 0. 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 But these three will remain intact, right? In between these three, there cannot be zeros, right? There cannot be zeros in the sense, we're assuming that all these elements will have 111 here. We're just assuming that. At this point, we're having 111 here, and we can fill these values with zeros. So we just need to identify how many bits are same in left and right, starting from the left. And how can we do that? Means initially our left is 111011010, right? So what I'll do, and my right is 1111010. So I'll check whether my left and right are equal or not. These two are not equal, right? Because the bits are getting changed. So I'll right shift our bits by one position. So these two values will be removed and we'll get 0 and 0 here, right? So I'll again check are these two values are same or not. Because of these bits, they are not same. So I'll remove these two again, and we'll get 0 and 0 at the left, right? Again, I'll check the left and right are equal or not. They are not equal because of we have 0 here, 1 here, 1 here, 0 here. So I'll remove these two. And again, I'll remove these two. And I'll remove these two. After removing these all elements, we'll have three bits which are equal, right? So this value will be 7. Value is also 7, right? So at the end, we'll have 111, and we just need to put zeros at this position. How can we put zeros at this position? We can just count the number of bits we have right shifted, and we can left shift the answer with those number of bits. We have right shifted with 1 2 3 4 5, right? So we can left shift with 5 bits to get the answer. So what is the time complexity? What is the time complexity means? Okay. The time complexity is order of log n, right? Or we can also say that it is order of 32. Since we are just doing right shift of a maximum of 32 bits and a maximum of 32 bits of left shift, right? So it will be order of 32 plus order of 32. It can be order of 64, which will be order of 1, right? So our time complexity is order of 1 and our space complexity is also order of 1. So let's see how are we going to do that. I'll just use a while loop. While my left is not equals to right, I'll just right shift my left with one position, and I'll right shift my right with one position. When in the meantime, I'll keep track of the count of number of bits that I have right shifted. Count plus equals to 1. And at the end I'll just return my left or right by left shifting the number of bits, right? That's it. Let's run this. Yeah, look at these. Yeah, it's running fine, guys. I know it's real. I know I haven't explained it very well, but it's a difficult problem to explain. Thank you guys for watching the video, and if you find the video useful and if you understand the topic that I have taught, just give a like. Thank you.